I am now working in clinical trials. I am a doctor, I am working on a clinical trial, and a drug company has already done a trial in which they've determined that for a new drug that they've created, that the incidence of headaches, they claim, is 13%. So here's the claim. The incidence of headaches among users of this drug is 13%. All right, so I am supposed to make an independent test of this. I do a clinical trial, and I have a sample of 44 people. Now, in my sample, I find out that almost 23% of them have headaches. That means I got a different result than they did, but does that mean their result is wrong? It's not really the same. To say that something was different in a sample doesn't mean that they're definitely different in a population. And in order to find that out, I'm going to need to do a hypothesis test. So, for a hypothesis test, there are three things I'm going to need: a null hypothesis, an alternative hypothesis, and a significance level. My claim is that the incidence of headaches among users of this drug is 13%. Is becomes equals. This is definitely a null hypothesis. So let me write my null hypothesis, which is my original claim. And that would be that. Now, what kind of parameter is this? I should have mentioned that too. The incidence of headaches among drug users of this drug is 13%. That would be a proportion. We're saying what proportion of the population gets headaches. So P equals, and I'm going to put 13%, but as a decimal, because it's a proportion now. If that's my null, what should my alternative be? Well, when I'm testing an equals claim, the best alternative I can use is not equal. P not equal 0.13. I don't have a convenient not equal button, but that's all right. I can just write it out. The other thing I want to know is, what am I working at? What significance or confidence? Well, I'm working at a 95% confidence, or at a significance. Significance is 0.05. All right, so now I'm ready to do my hypothesis test. Now, you'll notice here in column 1, I have all the results. No, 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 no. In fact, the first 7 apparently were all no's. But some people have headaches. It was either a no or a yes. We're going to ask Minitab to now test our sample data versus that null hypothesis. So, to do that, we're going to go up to stat. This is a statistical test. And we're going to go to basic statistics. Here, we are testing a proportion. We want to know that. That was very important. And we are doing so on one sample. So we are going to go to one proportion. Here, I do have one or more samples each in a column. If I had just told you there were 44 total people and this many had a headache, then I could do it as summarized data. If I click on the arrow here, you'll see I also have summarized data as an option. Here, I've actually got the data in a column. I don't have to count it up. And so I'm going to leave it there and then click in this box to tell it which column it is that I want to test. Well, I want to test C1 headache. Now, I need to click this perform hypothesis test box, because this time we used actually the same piece in Minitab when we did parameter estimation on a proportion, and then you wouldn't have clicked this box. But when you're doing a hypothesis test, this is how you tell Minitab this is not parameter estimation anymore, this is a hypothesis test. Minitab needs to know the hypothesized proportion. That word hypothesized tells you it's not the proportion of your sample data, it's the one that comes from your null hypothesis, which is 0.13. And then I'll click my options. I want to make sure my confidence level is right, and yes, I'm working at 95% confidence. My alternative hypothesis is a not equal, and with a proportion, just like with parameter estimation, I could do it based on a normal distribution, or I could do it the exact way, which is using a binomial distribution. So the exact way is better if you're using a computer. If you were doing it by hand, you would use the normal approximation, because it would be far too calculation intensive to do it any other way. So I'm going to say OK, and then I'm going to say OK. And here we see I have gotten a test of P equals 0.13 versus P not equal to 0.13. The event was yes, which is good. That's what I wanted it to be. 10 out of 44. 23% of them had headaches. Here's my confidence interval, and I notice it does include 13%, but I'm going to look at my p-value. My exact p-value is 0.115. Well, my significance, you'll remember up here, was 0.05. My p-value is greater than my significance If the P is high, the null can fly. Woo! Go null. So that means I fail to reject the null. I fail to reject the null. Now, let me state my conclusion in terms of the original claim. Remember the original claim, which I have gone down a little too far, but the original claim was the incidence of headaches among users of this drug is 13%. I am not saying that's true. That's a null. I never accept a null. Instead, I'm failing to reject it. There is not enough evidence, and you can say at 5% significance or at 95% confidence if you want, to reject the claim that the incidence of headaches among users of this drug is 13%.